Hi everyone, in Algebra 3, we are going to be doing our questions on lesson 61. The first one is, how many ways can a president, a secretary, and a treasurer be chosen from a class of 12 students? Now for this one, we're assuming that repetition is not permitted. So once you've been chosen for a position, you would not be eligible for the other positions. So I'm going to start with 3 boxes representing my president, vice president, or president, secretary, and treasurer. We're starting with 12 students that would be available for president. Then if I take one away, then there would be 11 for secretary, and there would be 10 for treasurer. So when you multiply that through, 12 times 11 times 10, you're going to get 1,320 different ways. Moving on to number 2, how many ways can Tom, Joe, Frank, and Sally sit in a row if Tom refuses to sit next to Sally? Well, this one's a little bit trickier because we're going to have 4 chairs, but we have to identify all the places where Tom and Sally can sit if they refuse to sit next to each other. So for my first box, I'm going to say that Tom and Sally are going to sit in these 2 spaces. For my second box, I'm going to say that Tom and Sally are going to sit in the second and fourth spot. And then for my last box, I'm going to say that Tom and Sally are sitting on completely separate ends of the row. So if I'm only choosing from Tom and Sally to fill this spot here, I'd only be choosing from 2 people. Once I've sat one of them, then there's only one left to sit in that third spot. Then the same thing for these spots. Anytime Tom and Sally, you're only choosing from Tom and Sally, it would be 2 for the first space and then 1 for the second. And then to fill the rest of the spaces, if Tom and Sally have already sat down, then I only have Joe and Frank left. So I'm choosing from 2 and then 1, 2 and then 1, and 2 and 1. So each of these will give me 4. My result is going to be 12. Now moving on to number 3, we have to arrive on time, it is necessary to average 40 kilometers per hour. If the wheels have a radius of 14 inches, what should be their average angular velocity in radians per second? All right, so for this one, we're going to be solving for angular velocity using the formula V equals RW. And to get the angular velocity by itself, you're going to multiply by the reciprocal, which is 1 over r. So that means the angular velocity is going to be equal to the velocity times 1 over the radius. Now the velocity they give us is 40 kilometers per hour, so I'm going to fill that in. Then I'm going to fill in the radius, so that would be 1 over 14 inches. And we want this in radians per second. So what I need to do is I need to eliminate all my units of measurement. So I'm going to go from inches to centimeters. So my inches cancel, then centimeters to meters. So 100 centimeters, 1 meter. And then 1,000 meters, 1 kilometer, and my meters are going to cancel. Then I need to convert from hours to seconds. So 1 hour, 60 minutes, and 1 minute, 60 seconds. So our minutes cancel, and then my hours cancel. And my kilometers also cancel. So I no longer have my unit of measurement. So my answer is going to be 40 times 100 times 1,000 all over 14 times 2.54 times 60 squared, and that's going to be, I'm going to add in my radian over seconds. And that would be your result for number 3. Moving on to number 4, a car has wheels that have a radius of 16 centimeters and the wheels turn at 40 revolutions per second. What is the speed of the car in miles per hour? So I'm going to start for number 4. The equation is velocity equals radius times angular velocity. My radius is 16 centimeters. And my angular velocity is 40 revolutions per second. The first thing that I'm going to do is I need to get rid of the revolutions, and the unit multiplier you use is 2 pi over 1 revolution. And the revolutions are going to cancel. Now I need to focus on getting this from centimeters to miles and seconds to hours. So centimeters to inches, 1 inch, 2.54 centimeters. Centimeters cancel. Inches to feet, so 1 foot, 12 inches. And feet to miles, 1 mile, 5,280 feet. So my feet cancel. Now I got to get from seconds to hours, so 60 seconds, 1 minute, and 60 minutes, 1 hour. So my minutes cancel, my seconds cancel. And there we are left with our result of 16 times 40 times 2 pi times 60 squared over 2.54 times 5,280. And that's going to be miles per hour. And that is your result for number 4. So using your unit multipliers on that one. Okay, moving on to number 5. A boat travels downstream in m nautical miles at d knots and then travels back upstream m nautical miles at u knots. What is the average speed of the entire trip? Okay, so we have average speed, our overall rate equals overall distance divided by overall time. And notice that knot is miles per hour. So that means knots is going to be our rate. And then, so our first distance is going to be m, and my rate would be d, which means my time is going to be m over d. Now for the second distance, I have m nautical miles, and my rate is going to be u knots, which means that my time is going to be m over u. So if I'm trying to find my overall rate, my overall distance would be m plus m. My overall time would be m over d plus m over u. Add the distances and then add the times. I'm going to make a common denominator. So that would be 2m over um plus dm all over du. And then to get rid of the complex fraction, I would multiply by the reciprocal. So that would be 2m du over plus dm. But what you need to recognize is that all 3 of those terms in this all have an m in it, which can all be canceled out, meaning that your answer is going to be 2 du over u plus d. and that would be your overall rate. Moving on, we're going to look at number 4. Number 6. Number 6 says Mike's wages for a 40-hour week came to $200. The next week, he received a 30% hourly raise, but was allowed to only work 38 hours. What was his paycheck for that week? So for number 6, the first thing that we're going to do is we find out how much he's paid per hour. So we take the $200 and divide it by a 40-hour week. That shows us that he makes $5 per hour. But then it says that he gets a 30% raise. So I'm going to take that $5 an hour and multiply that by 130%, or 1.3. And that means that he now makes $6.50 per hour. And it says he's only allowed to work 38 hours, so we're going to multiply that $6.50 by 38, which means that his new paycheck is going to be $247. Okay, moving on to number 7, we have 5 times Early's age now exceeds 4 times Lucy's age now by 38. In 5 years, twice Early's age will only exceed twice Lucy's age by 8. How old will Early and Lucy be in 13 years? So for number 7, I have Early and I have Lucy, and this is going to be their current ages. And then in 5 years, I'm going to have E plus 5 and L plus 5. That would be in 5 years. So it says 5 times Early's age now. So 5 times Early's age now exceeds 4 times Lucy's age now by 38. The second equation, we're going to use the in 5 years variables. So it says in 5 years, twice Early's age. So twice E plus 5 will only exceed twice Lucy's age by 8. So now what we're going to do is I'm going to distribute. That's going to give us 2E plus 10 equals 2L plus 10 plus 8. But notice that the 10s are going to cancel on both sides. And now what I'm going to do is I'm going to do elimination with this equation and this equation. And I'm going to do that by multiplying this equation by -2. So my top equation stays the same at 5E equals 4L plus 38. This bottom equation is going to become -4E equals -4L minus 16. So multiply -2, -2, -2. The L's are going to cancel, and you're going to be left with E is equal to 22. If E is currently 22, or Early is currently 22, I'm going to solve for L. And I can plug it into this equation here. So it'd be 2 times 22 equals 2L plus 8. Move the 8 to the other side. So 44 minus 8 should give me 36 equals 2L. Divide by 2. Gives me that L is currently 18 years old. But we want to know how old they're going to be in 13 years. So in 13 years, if I add 13 to this, I'm going to get 35. And if I add 13 to 18, I get 31. And these would be your answers. So make sure you're paying attention to the variables that you're going to be using in these. Okay, moving on to number 8, we have the ratio of tens digits to hundred digits, and a 3-digit counting number was 2 to 1. So number 8, I have tens to hundreds, that's just a fraction, is 2 to 1. So if I cross multiply that, I get t is equal to 2h. Then it says twice the tens digit, so 2 times the tens digit exceeded 5 times the units digit by 1. What was the number if the sum of the digits was 15? So that means the units plus the tens plus the hundreds all equaled 15. So now what I'm going to do is I'm going to plug this t into both of these equations. So that would become 2 times 2h equals 5u plus 1. And I'm going to bring the 5u over so that I get 4h minus 5u equals 1. Now I'm going to plug that into the bottom equation as well. So that would be u plus 2h plus h equals 15. I'm going to rearrange that so that I get 3h plus u equals 15. Now it's up to you if you want to do substitution or elimination with these two equations. I'm going to do elimination, so I'm going to multiply this equation by 5, leaving the top equation the same. So now I get 4h minus 5u equals 1. Bottom equation would become 15h plus 5u equals 75. When I add them together, I get 19h is equal to 76. And 76 divided by 19 is going to give me 4. So h is equal to 4. If h is equal to 4, then t is going to be equal to 8. And then I just need to solve for the units digit. So I can plug that in to this equation here, which is 3h, so 3 times 4 plus u equals 15. Move the 12 to the other side, which means that u is going to be equal to 3. It's asking what the number is. So if the hundreds digit is 4, the tens digit is 8, and the units digit is 3, the number would be 483. And that would be your result for number 8. Now moving on, we're going to look at number 13. So for number 13, the first thing that I'm going to do is I'm going to move the root 3 over 2 to, or root 2 over 2 to the other side. So for number 13, I would have cosine 3 theta is equal to negative root 2 over 2. Now I know that this is not a reference triangle because I don't have a reference triangle with an adjacent of square root of 2 and a hypotenuse of 2. So what I'm going to do is I'm going to move that square root down to the denominator by multiplying top and bottom by the square root. That would give me negative 2 over 2 root 2. If you simplify that, that would be negative 1 over root 2. And this, adjacent over hypotenuse, I do have a reference triangle for. So if I look at my chart, all students take calculus. I'm looking for where cosine equals a negative ratio, and cosine is positive in 1 and 4, so that means it's negative in 2 and 3. If the adjacent is negative 1 and the hypotenuse is root 2, I know that this is a 45-degree triangle. So for quadrant 2, I would set 3 theta equal to 135, because remember we have that 3 that's attached to the theta. And then for quadrant 3, I would have 3 theta is equal to 225. Remember though that we need to end up with 3 different answers for each of the quadrants. So theta is going to be equal to 45 for this first one, and theta is going to be equal to 75 for quadrant 3. But to find my other answers, I'm going to set 3 theta equal to 360. So theta is equal to 120, and this would be the difference between this number and the next one and the next one after that. So I'm going to add 120 to 45, which would give me 165. And then add 120 to that would be 285. And those would be my three answers for the first one. Now the second one, if I add 120 to that, I would get 195. And when I add 195 to 120, I would get 315. So in total, I should end up with 6 answers. Now moving on to number 14. So for number 14, the first thing that I'm going to do for this one is I am going to move the negative 1/4 to the other side. And that means I would end up with sine squared is equal to 1/4. Now I'm going to take the square root of both sides. And don't forget that when you take the square root of something, you get plus or minus its value. So I get sine theta is equal to plus or minus 1/2. Now I'm going to split that into two separate equations. So I'd have sine theta equals positive 1/2, and then sine theta equals negative 1/2. Now using my chart, all students take calculus. I know that sine is positive in 1 and 2, so I'm going to draw 2 triangles in quadrants 1 and then quadrant 2. I'm going to label my sides. This is opposite over hypotenuse. So opposite 1, hypotenuse 2, 1, 2. This means the adjacent would be √3 and negative √3. And that means that my degree for quadrant 1 is going to be 30 degrees. Quadrant 2, I would have to subtract that 30 degrees from 180, which would give me 150. For where sine is negative, since it's positive in 1 and 2, that means it's negative in 3 and 4. So I'm going to draw 2 triangles. Opposite hypotenuse, √3, negative √3. These are again going to be a 30-degree triangle. So that means theta is going to be equal to, in quadrant 3, it would be 180 plus 30, which would be 210. And then in quadrant 4, it's going to be 360 minus 30, which would be 330. And those would be your 4 answers. So each ratio had 2 answers. So now moving on to number 15. So for number 15, I noticed that in both of these terms, cosine squared theta and then cosine theta, I can factor out a cosine theta. So for number 15, I'm going to factor out a cosine theta. That would leave me with a cosine theta in the first term and a minus 1/2 in the second term. Now that I've factored out the cosine theta, what I'm going to do is I'm going to set each of them equal to 0. So I have cosine theta equals 0, and then cosine theta minus 1/2 is equal to 0. Now to get this cosine theta by itself, I would move the 1/2 to the other side. So I'd have cosine theta is equal to 1/2. Cosine is adjacent over hypotenuse. For this one right here, I'm going to use the unit circle. So I'm going to draw my chart. So cosine is equal to the x term. And then, which means, so if I underline all of my x terms here, there are 2 places where the x term is going to be equal to 0 degrees. So that means theta, the first place would be at 90 degrees. And the second place would be at 270 degrees. And those would be your first 2 answers. Then for the second one, I'm looking for where cosine is positive. So in my all students take calculus chart, I know that everything's positive in quadrant 1, and then cosine is going to be positive in quadrant 4. So I'm going to draw triangles in quadrants 1 and 4. I'm going to label my side as adjacent and then hypotenuse, adjacent, and hypotenuse. That means my opposite would be root 3 and negative root 3, and meaning that your angle is going to be 60 degrees. So for quadrant 1, it's 60 degrees, but in quadrant 4, you're going to subtract that from 360, so it's going to be 300 degrees. And those would be your 2 other answers. So altogether, you would have 4 answers for number 15. Now moving on, we're going to look at number 17. So for number 17, we have a log equation here. And anytime you see a plus sign between your logs, that means you are going to multiply your 2 variables together. So for number 17, I would end up with log x of x minus 9 equals 1. Now you're probably thinking, how do I get rid of the log because there's no base? Well, anytime there's a log with no base, the base is assumed to be 10. So I'm going to raise both sides to the power of 10. That would cancel out my log on the left side. And on the left side, I'd be left with x times x minus 9. On the right-hand side, I would have 10 to the 1, which is just 10. Now, if I set this equation equal to 0, I'm going to get x squared minus 9x minus 10 is equal to 0. And this would actually factor evenly into x minus 10 times x plus 1. Which means that I have technically 2 answers. I have positive 10 and negative 1. But remember that you need to check your answers. So if I plugged in the 10 back into the original, log of 10 is fine. 10 minus 9 is 1, and that's a positive number, so that works. But if I plug in negative 1, you can never take the logarithm of a negative number, so this would not be one of your answers. Your only answer would be 10. Now moving on, we're going to look at number 18. So for number 18, the first thing that I recognize is that in my exponent, I have a minus sign. So I want to combine those together. And I'm going to combine by dividing. So this would be 5 to the power of log 5 of 22 over 2. Then I see there's a number outside my log, which is going to go to the exponent. So this would be log 2 to the 4th to the power of 3. Anytime we have a parentheses raised to a power, you do multiply those 2 numbers together. So this would turn into 5 in the exponent. I have log 5 of 11 plus log 2 of 2 to the 12th. Now, if my base is 5 and my exponent has log 5 in it, those are going to cancel. If my base is the same as the base of the number next to it, that also cancels. So you're left with 11 plus 12, which is equal to 23. And that would be your result for number 18. Now moving on to number 19. So number 19 is the distance between a point and the line. This is going to be that 5-step problem, or maybe 4-step problem. So you're going to start with finding the perpendicular line that goes through that point. So perpendicular means that you take the negative reciprocal of the original slope, which would be negative x plus b. I'm going to plug in my point 4 and 2, so that would be 4 equals negative 2 plus b. That means b is equal to 6, which means my perpendicular line is going to be y equals negative x plus 6. Step 2 is to find out where this line and the original line are intersecting. And the way you find that out is by setting them equal to each other. So I'm going to set x minus 1 equal to negative x plus 6. Move the negative x to the other side. Move the 1 to the other side. And you would get 2x is equal to 7. Which means that x is going to be equal to 7 over 2. You are going to have to solve for the y coordinate at which they intersect, which means that you have to plug this number into either your new number, your new line, or your old line. I'm going to plug it into the old one, so that would be 7 over 2 minus 1. So 7 over 2 minus 2 over 2 means that y would be equal to 5 over 2. Now step 4 is going to be to find the distance between my original point and my new point. So it's x1, so 2 minus x2, which would be 7 over 2 squared, plus y1, which is 4, minus y2 squared. I'm going to make a common denominator. So I have 4 minus 7, which would be negative 3 over 2. And then I have 8 minus 5, which would also be 3 over 2. Now if I square that, I get 9 over 4 plus 9 over 4. Which would become 18 over 4. That can all be simplified into 3 square root 2, square root of 18 is 3 root 2, all over 2. And that would be your result. So 4-step problem, perpendicular line, set the two lines equal to each other, solve for y, and plug it into the distance formula. Moving on to number 20. So for number 20, we're going to have to complete the square to graph the parabola. So the first thing that I'm going to do is I'm going to move everything over to the right hand side. So I'm going to have y is equal to 2x squared minus 4x and then minus 7. I'm going to put all the x's in parentheses, so 2x squared minus 4x and then minus 7. Before I complete the square, I need to factor out a 2, so that would be 2 and then x squared minus 2x minus 7. When you complete the square, you take half the term attached to x, which would be 1. When I square that, that would be positive 1. But notice that if I were to redistribute this, this is actually a positive 2. So I need to do the opposite on the outside, which would be to subtract 2. Which means that this is going to be a positive parabola, faces up. I set x minus 1 equal to 0 to find my axis of symmetry, which would be at 1. This is going to be my vertex. And because I have factored out a 2, my normal chart, which looks like this, 1, 1, 2, 4, 3, 9, I actually need to multiply this whole row by this number, which is 2. So my new y is going to be 2, 8, and 18. Now I'm going to graph this. So my axis of symmetry is at 1. So at positive 1, I'm going to draw a dotted line. And then at negative 9, I'm going to put my point. So now from there, you're going to go over 1 up 2, over 1 up 2, and that would be in either direction. And then over 2 up 8. So 1, 2, up, 1, 2. Well, this would be 8 here. And then you connect your dots to create your parabola. And that would be your result for number 20. Now moving on to number 24, the central angle of a sector of a circle is 1.6 radian. Find the area of the sector in square centimeters if the radius of the circle is 1 meter. All right, so for number 24, I'm going to start by converting the radius from meters into centimeters. So 1 meter be 100 centimeters to 1 meter. So I'm using my unit multiplier, which means that my radius is going to be 100 centimeters. Now I need my formula for the area of the sector. In radians would be x over 2 pi times pi r squared minus r times r sine of x divided by 2. Now your radius you know, and your x is going to be the 1.6 radians. So 1.6, the pi's do cancel, divided by 2 times 100 squared minus 100 times 100 sine of 1.6 divided by 2. And don't forget on this one, because you're doing this in radians, you do have to convert your calculator from degrees to radians, and you press the DRG button for that. So now what I'm going to do is I'm going to do this side first. So 100 times 100 times 1.6 sine equals, then I'm going to divide that by 2. So that's going to give me approximately 4997.868. But I can actually do most of this in my head. So 2 goes into 1.60.8. So this would be, make that negative, then add it to 0.8 times 100 squared. And that means that my result would be 3002.13 centimeters squared. So I kind of just finished that off in my calculator because I was able to divide this portion by itself. And I just realized that I did that problem wrong, so I'm so sorry. That was not the area of the segment. That was supposed to be the central angle, so I need to redo that. That would really just be this portion of the equation. So really your answer would just be 1.6 divided by 2 times 100 squared. Oh, wait. 1.6 divided by 2 times 100 squared equals, and your answer should have just been 8,000 centimeters squared. I'm so sorry I did not read the problem correctly. This is not your answer. Now make sure you convert your calculator back from radians into degrees before you move on to the next problem. So make sure it says DEG at the top. Okay, so now moving on to number 25, which is the problem that I thought I was doing. So we're finding the area of the segment bounded by an arc of 150 degrees and the chord which joins the endpoints of the arc in a circle of radius 10 centimeters. So for number 25, the area of the sector is going to be x over 360 times pi r squared minus r times r sine of x divided by 2. This is the area of a sector. And this wants the area, it doesn't say to convert it, so we can leave it in centimeters. My x degrees is going to be 150, so 150 over 360 times pi times 10 squared minus 10 times 10 sine of 150 divided by 2. I'm going to do this in my calculator. So 150 times pi times 100 divided by 360 gives me 130.8997. My second part will be 10 times 10 times 150 sine, and then divide that by 2. And that would be just 25. And make that negative, and I'm going to subtract that from 130.8997, meaning that my result is going to be 105.9 0.90 centimeters squared. Okay, moving on to number 26, it says sketch the graph of the equation y equals x squared and x squared plus y squared equals 4. All right, so y is equal to x squared for number 26 is really just a parabola, and that's centered at 0, 0. So the axis of symmetry would be at 0, and the vertex would also be at 0. So it'd be over 1, up 1, over 2, up 4 would be my parabola. It would look something like that. Then my second one is a circle. That's also centered at 0, 0. The radius is 2. So in either direction, I'm going to go 2 spaces away and create my circle. And now I need to shade the region which matches this problem. So if it says that y is less than the parabola, that means that's going to be everything underneath the parabola. So that would shade all of this region. Underneath also meaning outside of the parabola. Okay. So that's the whole region that's covered by y is less than. When it said x squared plus y squared is less than the radius, that's everything inside of the circle. So everything less than the radius would be everything inside. So that would be all of this region. So your answer is going to be only the region that's inside of the circle, but under the parabola should be your answer. So inside of the circle, but under the parabola. Then lastly, we're looking at number 28. Negative 450 is greater than 360. So what I need to do is I'm going to add 360 to that, which is going to give me negative 450 plus 360 would give me negative 90. So really this is cotangent of negative 90 minus cosine of negative 90 over sine of negative 90, which is going to use my unit circle. Now, my unit circle, this is 0 degrees, this is 90, 180, 270, and 360. But if I go in the negative direction, this would be negative 90. So the coordinate here would be 0, negative 1. Cotangent is the inverse of tangent. So tangent is normally y over x, which means cotangent will be x over y. Cosine is equal to x, and then sine is equal to y. So if I'm looking at this equation, x divided by y would be 0 divided by negative 1. Well, 0 divided by negative 1 is just going to be 0. The cosine is equal to the x coordinate, which is 0. So that would be 0 over the y coordinate, which is negative 1. So really, this whole thing boils down to 0 minus 0, which is 0. And that concludes all of your questions on lesson 61. I hope you guys all have a great day. Bye.